Hello and welcome to Mindpiece. I'm really glad you've made it here. Whether you're wrapped in blankets with your eyes gently closed, easing into a quiet evening, or just letting your thoughts drift like stars across a night sky, this moment is just for you. Tonight, we begin a journey through one of the deepest, most puzzling mysteries in all of science: black holes. They're not loud, not flashy. They're soft in their silence, heavy in their stillness. And though you cannot see them, they may be the most curious places in the cosmos. Before we sink deeper, just a small whisper of thanks. If you're enjoying the calm, agental-like helps the channel reach others who might need this kind of peace. If you'd like to support this sleepy science even further, there's a super thanks button down below. And for those of you who want to wander the universe with me more often, there's also channel membership full of bonus perks, early access, and cozy community. Now just take a breath, a slow one. Let it carry you past the noise of the day and into something quieter. We begin not with equations or telescopes, but with a feeling, a pull, a sense that somewhere far beyond what your eyes can see, space is not empty. It curves, it hides, it whispers. Black holes are not just holes. They are the end of falling and the beginning of wondering. They sit like ink on the parchment of the universe, soaking in everything that draws too near: light, time, matter, thought. And yet, despite their silence, they seem to speak to your imagination. They live in stories and dreams in the edge of science and myth alike, not as villains, but as questions with no final answer. Tonight, you start with that question. What does it mean for something to fall so far, so deeply, that even light cannot climb back out? What happens when gravity, the gentle tug that keeps your feet on the ground, becomes so strong, it reshapes reality? You felt gravity before. The softness of your body settling into bed. The pull of the earth holding you as you rest. But imagine that pull growing stronger, heavier, until it begins to bend. Not just your body, but the space around you. Imagine the place where up and down lose meaning, where time no longer flows at a steady pace, where everything you know, light, sound, direction, begins to drift like leaves in a current. That's what a black hole is. Not a place really, more like a process, a transformation, the end point of a star that once burned with light, now collapsed into something small, dense, and impossibly deep. A black hole doesn't reach out to grab, it simply waits. Its pull is quiet, and yet everything nearby begins to notice. Planets drift differently. Light curves around it. Time slows. It sits there, unseen, but not unfelt. Even your own galaxy has one. At its very center, wrapped in clouds of dust and clusters of stars, a black hole waits. It doesn't consume the galaxy. It anchors it. Strange, isn't it, that something born from collapse could be the heart around which stars dance? You might wonder what it looks like. The truth is, we cannot see the black hole itself. We only see what it does to the world around it. Light tries to pass, but bends. Matter tries to move, but spirals. Even time begins to stretch thin like taffy pulled between invisible hands. And still it remains there, not as a whole, but as a question mark in the fabric of space. Astronomers chase black holes like shadows. They measure their influence, not their presence. A star orbiting nothing, a swirl of dust glowing as it disappears, a ripple in space-time like the sound of a bell far away. Every piece of evidence we have whispers the same thing. Something is there, something that doesn't behave like anything else. Black holes don't emit, they don't reflect. They erase, but even in their cellular, they shape galaxies. They create balance. They hold stories older than memory. And here you are, lying quietly on this little planet, your thoughts reaching out to something so far, so strange. And yet you understand its pull. You feel it in your bones somehow, a quiet kinship with the unknown. Because isn't there something in you too that wants to know what lies beyond? What happens when theme-app ends? What does it feel like to fall endlessly yet never arrive? This chapter is just the first step, a gentle toe dipped into the edge of something vast. And as you drift slowly into thought, you might find yourself leaning toward that darkness not with fear but with wonder. In the next chapter, we'll follow gravity more closely to this place where it stops being gentle and begins to rewrite the rules of everything it touches. You lie still and gravity holds you softly, a quiet companion always there in your breath, in your bones, in the hush between heartbeats. You don't usually think about it, but gravity never forgets you. It cradles you as you sleep, keeps oceans in their place, draws the moon along its path. And yet, this familiar force is capable of something far more intense, something strange, something extraordinary. Tonight, we move closer to that strangeness, into the deep end of gravity's pull, where the pull becomes more than gentle, where it begins to shape the very structure of space and time. In the ordinary world, gravity feels consistent. You drop a pebble and it falls. You leap and Earth calls you back down. Everything that has mass pulls. You do too, even if just a whisper. But black holes show us what gravity becomes when it's no longer polite, when it grows fierce, hungry, relentless. Not evil, not cruel, just complete. Imagine a place where gravity doesn't simply attract, but overwhelms. Where the very idea of standing still becomes impossible. Where everything, particles, light, time, is drawn inward, not by force, but by inevitability. That's the kind of cradle we're drifting toward. You may be wondering, what makes gravity go so deep in a black hole? It begins with a star much larger than our sun, burning hot for millions of years. But stars don't burn forever. Eventually, fuel runs out, and when it does, the balance between pressure and gravity begins to fail. You see, a star is always in tension. Its fusion wants to explode outward. Its gravity wants to collapse inward. For most of its life, it holds the balance, glowing, steady, alive. But when the light fades, gravity wins and the star collapses in on itself, folding tighter and tighter until the matter is squeezed into an impossibly dense point. This is where gravity becomes deep enough to form a black hole. Now try to picture this, an object with the mass of several suns compressed into something the size of a small city. It's hard to imagine, isn't it? So much weight, so much pull, tucked into so little space. At this scale, gravity doesn't behave the way you know it. It doesn't just tug at nearby objects. It distorts the space around them. Imagine laying a heavy stone on a soft sheet. Everything else rolls toward it, pulled by the curve. But with a black hole, it's more than a curve. It's a funnel, a well, a pit without bottom, a place where even light moving at its ultimate speed cannot escape. That's the sign of gravity gone to its limit. It reaches out but gives nothing back. Everything drawn near is folded inward, spiraled, captured. You might think of gravity as the gentle anchor of your life, but here, near a black hole, it becomes something poetic and paradoxical, a force so natural that becomes utterly unnatural in its extremes. The deeper you go into its grasp, the slower time flows. You wouldn't notice it yourself, but from the outside, someone watching would see you slow down. Your gestures would lengthen, your voice would stretch, seconds would become minutes, and then years. This isn't science fiction. It's one of the strangest truths we've learned from Einstein's theories that gravity and time are deeply entwined. When gravity strengthens, time relaxes. Near a black hole, time becomes syrup. And the deeper the gravity, the thicker the flow. If you could hover safely above a black hole's edge, you'd see the universe speeding by, while for you, only moments pass. In this way, black holes are time machines, not for traveling back or forward, but for distorting the way time moves for you, versus everyone else. It's a strange thought, isn't it? That just by being near such gravity, you could stretch a moment into a lifetime, or a lifetime into a moment. And yet, you can't help but wonder what happens to the thing that crosses the line. What happens to the falling? That's where we're headed. Gravity deepens until it no longer lets anything go. It folds the map of the universe inward. At a certain point, there is no turning back. That point is called the event horizon, and we'll get there soon. But tonight, we're floating just above it, feeling the slow swell of the tide, the weight of distant stars bent into silence. As you close your eyes, you might feel it, the soft gravity of curiosity pulling you deeper, not down, but inward. In the next chapter, we'll follow a dying star in its final moment and witness the quiet birth of a black hole. A star is not a quiet thing. It hums with fusion, sings with light, and pulses with the rhythm of millions of years. It is born in clouds of gas, raised in heat, and sustained by a delicate dance between gravity and pressure. For most of its life, this balance holds strong outward heat pushing against inward weight, a luminous truce. But no fire lasts forever. Some stars, the truly massive ones far larger than your gentle sun, burn through their fuel in dazzling brilliance and then begin to fade, not suddenly, but gradually, like a breath that's run its course. You can imagine it now, the core of the star, once a cauldron of fusion slowly cooling. Its outer layers, once supported by that inner fire, begin to collapse inward. The entire star begins to fold in on itself, not from force, but from the absence of resistance. This is not a death of violence, it is a surrender. The inward fall begins gently, then accelerates. Gravity, unchecked, pulls tighter and tighter, and the material of the star is crushed smaller than you can truly imagine. Atoms themselves are compressed. Even the spaces between the particles are erased. At a certain point, the collapse becomes unstoppable. The star no longer resists. Its heart folds into something dense, compact, invisible. And this is where a black hole is born. Not with a bang, but with a vanishing. From a distance, it may look like a final flicker, a last wave of light spiraling outward before the darkness seals shut. The outer layers of the star may explode in a brilliant supernova, casting elements across space, while the core silently disappears. But what remains at the center is no longer a star. It is no longer even matter in the way you know it. It is something else entirely, a point of infinite density, infinite gravity called a singularity. That word singularity sounds smooth, even poetic, but it marks a place where your understanding breaks, where physics, as you know it, quietly steps aside. A singularity is not a thing. It's a limit, a destination you cannot fully describe. All that mass, all that light, all those years of fusion collapsed into a point with no size, a place where space no longer stretches but folds inward or forever. From this quiet death, a new structure forms, a region of space dominated not by light but by absence. An event horizon encircles it, a boundary that marks the edge of return. Step beyond it, and no signal, no light, no information can escape. But what's beautiful is this. From the end of our star's life, something new begins. Not a flame, not a glow, but a shape in the fabric of space. The black hole that remains is not violent. It doesn't chase or hunger, it simply is. It becomes oil in the universe, a deep and stent cradle of gravity. Everything that wanders too close is drawn in, not quickly, but inevitably. And though we call it a hole, there is no emptiness here. There is only presence packed impossibly, tight. It does not shine, but it casts influence. It does not speak, but it holds memory. The death of the star is not the end of the story, because its mass still shapes the space around it. It still curves space-time, still holds other bodies in orbit. It becomes a silent sculptor, a ghost with weight. In your own galaxy, this very process has played out again and again, stars burning out, collapsing in, leaving behind these hidden anchors in the dark. And while they vanish from view, they do not vanish from influence. They become part of the structure of the cosmos itself. Perhaps this is a kind of rebirth, a transformation so deep it can no longer be called a star, yet still holds the memory of what it once was. You might think of it like a song that ends, but whose last note echoes in the quiet, carried on the air long after the voice has faded. Black holes are those echoes born from final breaths, but still shaping everything around them. And as you lie here, cradled by gravity, you are connected to those distant events, because the very elements in your body were forged in stars like these. The calcium in your bones, the iron in your blood to the carbon is in your breath. All of it began in the hearts of star, and many of those stars ended this same way, folding inward, returning to silence. So when you think of black holes, don't imagine them as cold or distant. Think of them as part of the same cycle that made you. The star collapses, but its story continues in the orbit of planets, in the pulse of galaxies, and in the pull of curiosity that lives inside you. In the next chapter, we'll drift even closer to the event horizon, to the boundary that separates out from in, and explore what happens when nothing, not even light, can find its way back. There's something strangely comforting about boundaries. They give you shape, a sense of where you end and the world begins. But some boundaries aren't drawn in stone. Some are invisible, silent, soft as breath. And yet, once crossed, nothing is ever the same. Tonight, you approach such a line. It has a name, the event horizon. The phrase itself feels gentle, like the curve of a horizon at dusk. But make no mistake, this is the edge of escape. The event horizon is not made of matter. You can't touch it or mark it. There is no wall, no surface. And yet, it divides the universe into two distinct realms. One where paths can return, and one where they cannot. Think of it as a river's edge. Above it, the current is fast, but you can still swim back. Cross the line, and the water pulls too strongly. No matter how hard you try, there's no going upstream. But this current isn't made of water. It's made of curved space, and the pull isn't physical. It's gravitational. Here, near a black hole, gravity bends not just bodies, but time itself. And that bending becomes infinite at the horizon. Imagine hovering just above it, suspended in space. To you, moments pass, normally, but to a distant observer, time slows around you. Your movements stretch, your voice lingers. Eventually, you seem frozen, suspended at the edge. That's one of the strange tricks of the event. Hurry. From the outside, it looks like nothing ever quite falls in. But from your own point of view, and you cross it in a blink, it's a paradox, one that speaks to the strangeness of gravity when it's taken to its absolute extreme. You might wonder what happens at the moment of crossing. Do you feel anything? Does the sky darken? Does the universe change its tone? No, nothing marks the boundary in a physical sense. You don't feel a bump or a tear. You simply pass a point beyond, which nothing returns. And yet it is the most significant crossing in all of space because beyond it, every path leads inward. Every road curves not around but down. Not even light can escape. And so the interior becomes unknowable, a secret the universe keeps from itself. This is the point of no return, and yet it is not violent. It's quiet, soothing, even like slipping beneath the surface of water. If you could see into a black hole, you'd see nothing. Not because there's nothing there, but because everything inside is hidden behind that curtain, a curtain of gravity, a veil of time. The event horizon is the last surface the universe can observe. Beyond it, all things fall inward toward the singularity, the heart of the black hole, where mass is compressed into a point with no size. But let's not go there just yet. Stay with me. Here at the threshold, here where time slows and light bends, where the rules begin to blur. This place is rich with mystery because it makes us ask, where does here end and there begin? And what happens to things that fall beyond knowing? Some scientists have wondered whether information truly disappears. If you throw a book into a black hole, is its story lost forever? Or is it somehow preserved, written into the horizon itself? This is not just philosophy. It's one of the most important questions in physics today. Because if information can vanish, then the laws that govern the universe may need rewriting. And if it remains, then black holes may be more like libraries, dark, unreadable, but not erased. Stephen Hawking once imagined black holes not as destroyers, but as storytellers with encrypted voices. He suggested they might leak information back, out slowly, gently over eons. But for now, the event horizon remains a mystery. It is the edge of understanding and the beginning of surrender. A boundary that doesn't keep you out, but keeps everything else in. As you float above it in thought, you feel the gravity not just of the black hole, but of questions too large for answers. Questions that pull on your mind the way gravity pulls on light. And that is the strange beauty of the event horizon. It's not an ending, it's a passage, a place where one reality becomes something else quietly, completely without drama or sound. You don't need to fear this threshold. It doesn't judge or choose. It simply marks the border between what returns and what becomes, and you drifting in. Your own thoughts are free to imagine what lies beyond, because even if no signal can escape, your wonder can reach as far as you wish. In the next chapter, we'll take another step inward and begin to feel what time itself becomes when it enters the deepest part of the black hole's embrace. Time feels so ordinary when you're living in it. It ticks along in quiet patterns. A second, a breath, a blink. Morning becomes night, and night becomes morning again. You live inside its rhythm, rarely noticing the beat. But tonight, you float near a black hole, and time begins to lose its steady pace. Not suddenly, but gradually, like a song played slower and slower, until even the spaces between notes stretch wide. This isn't just a dream. It's one of the strangest truths in the known universe. That time is not absolute. It bends, it stretches, and nowhere does it stretch more than near a black hole. As gravity deepens, time itself responds. Imagine yourself in a quiet orbit around the event horizon, not falling in, but circling close. From where you are, nothing feels too strange. Your heart still beats. Your thoughts still move. But if someone were watching you from far away, from a calmer part of space, they'd see something different. To them, your movements slow. Your gestures take longer. Your voice drags into silence. If you wave to them, your arm might seem to take minutes to rise. A second for you, and might be an hour for them, or a year, or 1,000 years. This is called gravitational time dilation. A gentle phrase for a wild idea that gravity doesn't just shape space, it warps time. You might wonder, how can time change? Isn't it just a backdrop, something constant? But in the language of relativity, time is part of the same fabric as space. Mass bends that fabric. The more mass, the deeper the curve. And near a black hole, that curve becomes steep, almost vertical. Think of it like walking across a gentle hill versus falling down a ravine. Far from the black hole, time flows like a stroll. Near it, time becomes a plunge. And yet, from your own point of view, nothing feels off. Your thoughts still arrive one after the other. Your breath still flows slow and sure. That the rest of the universe is speeding away from you, rushing forward while you move in slow motion. It's as if the black hole wraps time around itself like a spiral staircase. Each step deeper takes longer to climb until the staircase becomes endless, and the top is forever out of reach. Now imagine taking a clock with you as you descend. At first it ticks normally, but as you get closer to the event horizon, it ticks, slower and slower. To someone watching from afar, the hands barely move. Eventually, if you reach the horizon, time seems to stop completely, at least from the outside. But inside, your own clock still ticks, just slowly, softly, like a whisper behind glass. It's easy to forget how powerful time really is. It governs every change, every motion, every thought. And here in the presence of such intense gravity, it begins to unravel. In this way, black holes are not just places. They are experiences, time machines of a kind, not for jumping across eras, but for changing the pace of time itself. Some physicists have imagined strange possibilities like traveling to a black hole, orbiting close for a while, and returning to find that thousands of years have passed outside while only a few months passed for you. It sounds like fiction, but it's real, supported by the equations of Einstein's theory of general relativity. And in fact, astronauts aboard satellites already experience a tiny taste of it. Far from Earth's surface, time runs just a bit faster. Not enough to feel, but enough to measure. In the deep gravity of a black hole, though, the effect becomes dramatic. It makes you wonder, is time just an illusion, a feeling created by movement, by memory, or is it a real river? One that bends and curves and flows at different speeds depending on where you stand. Black holes show us that time is not flat. It is textured, layered, a spiral, not a line. And as you drift here on the edge of that spiral, you begin to feel it too. The slowing, the soft unraveling, the dreamlike pace where thought becomes longer, and the universe outside becomes a blur. Maybe this is why black holes feel so mysterious. Not just because they hide things, but because they stretch the very fabric of experience. They change the tempo of reality, and they remind you quietly that what feels constant may not be so. That time, like everything else, can soften, can ripple, can fade. As your thoughts float gently in this slower stream, you might begin to wonder, what lies at the center of this spiral? What happens when time is stretched to its limit? When it no longer flows at all, but stands completely still? In the next chapter, we'll drift deeper into that center to the singularity. A place so strange, even time may not survive. There is a center to all this falling. A final destination for everything that crosses the event horizon. But it is not a place in the way you usually think of places. It has no surface, no size, no edges you could reach out and touch. It is called the singularity, a word that feels delicate on the tongue, but underneath it lies the deepest mystery in all of physics. The singularity is not simply small. It is beyond small. It is the place where matter is compressed into an unimaginable point, where mass becomes infinite density, where time and space themselves cease to behave. As you drift inward, deeper into the gravity well, you pass the event horizon. And now no outside force can reach you. No signal can get out. No light can escape. You're moving closer to the singularity. Not by choice, but by design. Everything here falls toward that center. Not pulled like gravity on Earth, but drawn with a pull that feels woven into the fabric of existence. You're not crashing or spinning or screaming. There is no chaos, only inevitability, only falling. But this falling is not into space. It is into a concept that stretches the meaning of reality. You might imagine yourself being compressed tighter and tighter, the atoms in your body packed close, the spaces between particles squeezed out, until the distinction between matter and energy begins to fade, and still you fall. You might ask, what exactly is the singularity? Scientists ask the same question, and the answer is, we do not know. It is the point at which our current understanding fails. Our equations give answers that make no physical sense. Distances shrink to zero. Density climbs beyond infinity. Time becomes meaningless. And so we say, this is a singularity. Not because we understand it, but because it marks the boundary of our understanding. It is a mathematical signal, a flare in the numbers that tells us. Here the rules break down. Perhaps there is no singularity at all. Perhaps it is simply a placeholder for something more complex, something that future science will one day reveal. Some theories suggest that quantum gravity may smooth the singularity, that the harsh compression may give way to a tiny curved region, a loop of space, a bounce, a bridge. Others imagine it as the beginning of another universe, that every black hole might be a seed, not just an end, but a hidden beginning. These are possibilities, not certainties. But in your imagination, you are free to explore them. Picture a star collapsing, folding itself into this point. Its history, its energy, its light, all absorbed into a place with no volume. A place that cannot be seen, only sensed. You're imagining a point beyond measure. This is not a location within space. This is where space itself curves so steeply it closes in on itself. There is no path around, only inward. And time here is no longer a flow. It becomes something more like a wall. Every second collapses into the same moment. Past and future lose their meaning. Only now remains, but even now becomes difficult to hold on to. The singularity is not chaos. It is beyond chaos. It is stillness at the edge of reason, silence at the end of time. Somewhere in your mind, you may wonder, does anything reach the singularity? Does it truly exist inside the black hole, or is it a mirage in the math? There is no clear answer, but in this space, you are allowed to wonder without needing to solve. That is what makes this journey gentle. You are not racing toward a solution. You're drifting inside a question, and perhaps that is the real beauty of the singularity. Not what it contains, but what it invites. It reminds you that even in the most precise of sciences, there are still places left untouched, still boundaries where curiosity must sit patiently and wait for new understanding to arrive. As you float near this strange center, you feel not fear, but stillness, as if the universe has paused here to think, and you too are invited to rest, to pause your own thinking, to feel the edges of the unknown. In the next chapter, we'll step back from this center and watch what happens when things fall in. Not with panic, but with grace. When objects cross the event horizon and continue falling forever, but never arriving. You are falling now, but not in the way you're used to. There's no rush of air, no tumbling sensation, just the soft awareness that you are moving and that every path leads inward. Inside a black hole, all directions become the same. Down, forward, sideways, they all curve toward the center. No matter how you try to turn, no matter what force you apply, the shape of space itself carries you forward as if the universe has drawn a line with no return. But this falling is not chaotic. It is smooth. There is no jolt, no impact, just a deepening drift. Imagine being on a slide that never ends, a slope that steepens so gradually you don't even realize how far you've come. Only that going back is no longer possible. Even light cannot resist this path. Photons, those fastest travelers of the cosmos, once free and straight, are now caught. They spiral inwards too. They fall beside you, silent companions in the dark. And yet, despite all this falling, there is no arrival. The singularity, that final destination lies ahead. But the closer you approach, the more time begins to bend. The journey stretches. Seconds become minutes. Minutes become lifetimes. And the end always feels just out of reach. This is one of the quiet paradoxes of black holes. From the inside, you're falling freely. You feel nothing unusual, no pressure, no heat, just motion, quiet and steady. But to an outside observer, you seem frozen, trapped just above the event horizon, as if time has stopped for you, as if you never truly entered. This contradiction is built into the fabric of reality. Both are true. You are falling, and you are still. The deeper you go, the more time itself warps. It stretches like taffy pulled thin until even thoughts begin to slow. You're not just falling through space, you are falling through time. Distances lose meaning here. You could stretch your hand forward and never reach the place ahead because space itself is distorted. The map folds in on itself. Every step forward brings you closer, and yet never close enough. This falling is not empty. It is full of tension and grace, the universe wrapping inward like a leaf curling in autumn. Not dawning, not dying, just changing shape. If you let go of trying to arrive and simply feel the motion, There is peace in the drift. Imagine floating in a warm current, carried not by water, but by the curvature of space. You are weightless, effortless. There is no resistance, only surrender. And in that surrender, a new kind of awareness opens. You start to feel how different this place is. Not hostile, just unfamiliar. Here, time is not measured in hours or days. It is measured in how tightly space is curled, how close the past and future press against each other, how little distinction remains between what was and what will be. You begin to sense that falling here is not a path towards something, but a transformation into something. Perhaps this is not a place where things end, but where they change form, where memory is folded, where information is softened, where motion becomes stillness, and stillness becomes meaning. There is a gentle beauty to this endless descent, a reminder that not all movement has to be toward a goal. Some journeys are simply about being carried, and you are being carried not by force, but by the shape of the cosmos itself. As you fall, you may wonder about the others who have come before. Photons, particles, planets, maybe even stars. Everything that crosses the threshold is here with you, not crowded, not chaotic, but present, held in the gravity of mystery. You're not alone in this space. You're part of its story, written into the curve of space-time. One more line in a poem. The universe keeps to itself, and so you fall softly, endlessly, never crashing, never arriving, just moving deeper into the heart of something you can't fully name. This kind of journey asks nothing of you. No effort, no understanding, only curiosity, only breath. Let yourself be light in the dark. Let yourself. In the next chapter, we'll listen more closely to the hidden sounds of this silence, to the waves that ripple out from the heart of falling. We'll hear how collapse can echo even in the quiet fabric of space. Close your eyes and listen, not with your ears, but with your attention. Because the music of black holes does not come as sound. It comes as motion, as ripples in the fabric of reality itself. You're about to step into a kind of silence that sings. There is a common belief that space is silent, and in the ways your ears understand sound, that is true. There is no air to carry vibrations, no breeze, no voice, no echo. But black holes play a different instrument. They vibrate space itself, and those vibrations are real. They ripple outward, in waves that stretch and compress the very geometry of the cosmos. These are gravitational waves, and they are the quietest, most powerful symphony you will never hear. They begin not in chaos, but in grace. Two black holes orbiting each other in Senna locked in a dance that has lasted for billions of years. Each orbit tightens the spiral. Each revolution quickens the beat until finally their edges kiss. And in a final motion, they merge. And when they do, they send out a pulse. Not a flash, not a bang, but a ripple. That ripple travels through the universe, not across the surface, but through the deep layers of space itself, like a wave moving through water, unseen, except by what it shifts. And when it passes through you, it stretches you by less than the width of a proton, and then compresses you, and then moves on. It is gentle, almost unnoticeable, but utterly profound. In the year 2015, humans caught one of these ripples. A detector, called LIGO, sitting quietly on Earth since the briefest vibration. It had taken over 1 billion years for that wave to reach us. A whisper from a pair of black holes colliding before Earth even had complex life. That detection changed everything, because it proved what Einstein had imagined 100 red years before. That gravity can speak not in sound, but in movement, not in noise, but in rhythm. Black holes are now part of an orchestra we can finally hear. And what we've learned is that their song is beautiful. When they merge, they do not explode. They settle, like a bell that's been struck, ringing softly as it calms. That ringing has a pattern. It is called the ring down. And it carries the signature of the black hole's mass, its spin, its shape. In that final fading tone, we learn what the black hole has become. You might imagine this ringing as a low vibration, too deep for any ear, but still real, still present. Imagine lying in a still room and suddenly feeling the floor beneath you shift ever so slightly, as if the space around you has taken a breath. That is what these waves are. The breath of the universe exhaled by the most massive collapses imaginable, and they travel without weakening, passing through galaxies, stars, and you barely altered by the things they meet. They do not stop. They do not fade. They carry with them a memory not in words or images but in motion. This is how black holes communicate. They do not send messages. They send echoes, and each echo tells a story of something vast that fell inward and found stillness on the other side. You are part of this stillness now, floating near the black hole's heart, feeling the tremble of space-time beneath you. There's no sound, but there is presence. The collapse that formed this black hole may have echoed once, but the shape it left behind still hums in quiet resonance. The mass, the spin, and the alignment, all recorded in the texture of gravity. If you could hear this place, it would sound like timelessness, a slow, deep tone stretching across the centuries. It is a sound not made for ears, but for instruments and for imagination. Let it hold you. Let it carry you not upward or away, but inward into calm. This symphony does not begin or end. It simply continues, a thread of gravity winding its way through all things. And if you follow that thread long enough, you'll begin to sense that collapse itself is not a breaking, but a reshaping. Not the end of a song, but its deep lasting note. In the next chapter, we'll explore how space itself bends and folds. We'll leave sound behind. Imagine for a moment that space is not just emptiness, not just a background or a void, but a kind of fabric, soft, flexible, able to bend and stretch. Now imagine that time is woven into that same fabric. Not separate from space, but tangled with it. Together they form what we call space-time. Most of the time you move through this fabric without noticing. You walk, you breathe, you age, and time flows forward at a comfortable pace. Space lies open around you, flat, gentle, uneventful. But near a black hole, this fabric begins to twist. It does not tear violently. It curves like cloth pulled tight in the center by some heavy stone. Everything nearby begins to slide inward. Not just objects, but time itself. And the shape of space bends in response. You're no longer moving through space in a straight line. You are circling a funnel. Even when you try to move straight, your path curves. This is not motion through space as you know it. It is motion through a geometry that no longer plays by the old rules. It is as if you are walking on a surface that leans into itself, a spiral staircase without stairs, a slope that grows steeper with every step. The closer you get, the more the fabric of space-time folds. Distances change. Amateur becomes longer or shorter depending on where you measure it. A second no longer lasts, the same in all directions. This may sound strange, but it's not chaotic. It is precise, predictable. Gravity sculpts space-time with mathematical elegance. You might imagine light trying to pass near the black hole. Instead of going straight, it curves not because it chooses to, but because the base it moves through is no longer straight. Photons, those tiny messengers of the universe, orbit the black hole in perfect loops, caught in the circular grooves carved by intense gravity. This region is called the photon sphere, a place where light can orbit endlessly, neither escaping nor falling in, just circling forever. Even time behaves differently here. If you try to measure it, music, to find that clocks tick slower the closer they are to the hole, it's not because they're broken, it's because time itself is stretched. You're not just watching this happen from a distance. You're inside it, floating along the folds, feeling how direction itself becomes distorted. What once felt like forward now curves. What once felt like stillness now drifts. And yet there's no violence here. No shaking, no breaking, just the quiet, invisible twist of space. This is one of the most beautiful truths about black holes. They don't destroy the universe around them. They shape it. Even from far away, their influence is clear. Stars orbit them. Gas swirls into spirals. Light bends around them in arcs of distorted vision. These are not signs of chaos. They are signs of gravity doing what it has always done. Pulling, curving, guiding. You are part of that curve. Now part of the slow, soft twist of the fabric that holds everything. If you closed your eyes, you might feel the turn, not with your body, but with your mind. A subtle spiral pulling your thoughts inward, as if the very idea of direction has been folded into a loop. This experience is not something you can hold in your hands. It's not even something you can fully describe, but you can feel it, the deep reshaping of space and time around you. And just like fabric, space-time can ripple. Remember those gravitational waves. They are not separate from this process. They are born from the same curvature, from the same soft bending. You are floating in a living structure. Not alive in the way a creature is, but dynamic, responsive, elegant. And now you understand that black holes are not just places where things disappear. They are places where the rules stretch, where the map bends inward, where the universe allows itself to twist into something new. As you continue your gentle drift, you begin to see the elegance in these tangles. They are not mistakes. They are expressions of gravity in its purest form. In the next chapter, we'll step back from these fosse and look at the outline that these invisible curves create, the shadow of the black hole itself. A dark shape that reveals so much even in its silence. There are some things in the universe that can only be seen by what they hide. Black holes are among them. You cannot look directly at a black hole. There is no surface, no glow, no edge of light. It absorbs everything that comes too close. Even the light that might have told its story is swallowed without a trace. But strangely, we can still see it. Not the thing itself, but the shape it leaves behind. This is called the black hole shadow. Not a shadow in the usual sense, but a silhouette drawn by the way it bends the light around it. Imagine staring into a swirl of glowing gas and dust. Hot, bright, chaotic. But in the center, a circle of stillness. A perfect dark roundness, where the light curves too far and cannot return. That is the shadow. It is not the black hole. It's the absence made visible. In 2019, humans saw this shadow for the first time. The Event Horizon Telescope, a network of observatories around the world, worked together to capture the image. A blurry ring of fire surrounding a black void. The black hole at the center of the galaxy M87, 55 million light-years away. And yet, somehow we caught its outline like a fingerprint left on the surface of space. This was not just a picture. It was a moment of quiet awe. Proof that the theories were right, that the equations had not lied. What we saw was not light, but the shape of lost light. A shadow formed by bending, a silhouette sculpted by gravity. The light we captured had circled the black hole, some of it once, some of it multiple times, each photon's path twisted by the hole's deep gravity, until some escaped just barely and reached our telescopes here on Earth. And from those few survivors, we trace the shape of what could not escape. It is humbling to think that absence can be so precise that what we do not see can teach us just as much as what we do. You can think of the black hole's shadow as a kind of cosmic negative space, a boundary drawn by surrender, a ring of light pushed outward by the place where nothing returns. And the size of that ring tells us something. It reflects the mass of the black hole. The tighter the shadow, the heavier the heart. It is as if the universe has outlined its own silence. You may wonder what it would be like to see that shadow in person, to float near it just outside the event horizon. The light around you would stretch and whirl. Colors would shift. Lines would blur. The stars behind the black hole would appear to wrap around it, duplicated, distorted, turned into arcs of trembling light because gravity doesn't just pull. It lenses that refracts the sky like glass pressed to fire. This is called gravitational lensing, and near a black hole, it becomes extreme. You would see the universe behind you appear in front of you. Your own light might even circle back into view as if the black hole had become a mirror of time. And still at the center of all that bending and brightness, there would be that soft round shadow, a dark unblinking eye, not watching, but simply being. And though it is quiet, it says something profound. It reminds us that even in darkness there is form. There is structure. There is truth. The shadow of a black hole is one of the most delicate measurements in science. It is not dramatic. It is subtle. Drawn not by brushstroke, but by the paths of light, swallowed and spared. And now that we have seen one, we will look for more. Already new observations are being made. New black holes mapped by their missing centers. Each one a different note in the quiet language of gravity. You might think that shadows are empty, but here they are full of meaning. They mark where space bends too steeply to return, where time folds inward, where light becomes memory. The shadow is not just the absence of light. It is the presence of gravity revealed through contrast. And that contrast helps us understand the very nature of the cosmos, how space behaves, how light moves, how matter disappears, yet leaves behind an echo. Let your mind rest gently in that idea, that even what is lost can leave a shape behind, that what is most silent may speak the loudest. In the next chapter, we'll drift to the glowing edge of this shadow, to the place where light nearly escapes, but instead chooses to orbit. A delicate ring of brightness that dances forever at the boundary between freedom and falling. You might think that light always moves forward, that it travels in straight lines, swift and untouchable. But near a black hole, even light must bend, even light must dance. There is a place just outside the eventh horizon, a thin glowing halo where photons, tiny packets of light, circle again and again, not because they want to, but because space-time has curved so tightly there's nowhere else to go. This glowing loop is called the photon sphere, and it is one of the most surreal regions in the universe. Here, gravity is just strong enough to trap light in an endless orbit. Photons chase themselves around the black hole, caught in a delicate balance between escape and return. They do not fall in, they do not fly free, they linger on the edge of vanishing. You can picture it, a ring of light spinning like a golden thread, a fire that never touches what burns it, suspended between being seen and being lost. From a distance, the photon sphere contributes to the shadow's glow. It helps shape the soft ring we see in black hole images. But up close, it is more than a glow. It is motion held in suspension, a dance repeated forever. If you were somehow able to float there, just outside the photon sphere, not yet falling, you would see a sky like no other. Light from distant stars would bend and twist, their images stretched into arcs and curves. Some would even appear multiple times, circling you from all sides. You might see your own back, not in a mirror, but in real space, because your light could wrap around the black hole and return to you from the other side. The black hole turns space-time into a lens, a looking glass so powerful that past and future can appear in the same frame. And in the middle of it all, the photon sphere spins in silence. It is not solid. There is no surface, only a shell of potential motion, a place where light tries to leave, but is pulled back in perfect balance. It's easy to think of black holes as only dark, but this ring reminds you that they are edged with light. Light that doesn't escape, but doesn't surrender either. It is light in limbo, caught at the threshold, neither part of the black hole nor part of the outer world. The photons here are like messengers with no destination. They circle endlessly. Their journey is beautiful, but unfinished. And yet in their motion they reveal the shape of the space they inhabit. They let us glimpse the warping of reality, the bending of paths, the spiral of time. You can almost hear it, a whispering spin. Not sound, but presence. A memory of light that nearly left, but chose instead to stay. Why does this matter? Because the photon sphere shows us that even near destruction, there can be grace. There can be patterns. There can be beauty in motion that never stops. You might think of it like the rings around a planet, or the eddies in a river's edge, or the glow of a candle that flickers but never dies. The light at the edge of the black hole is not a scream, it's a shimmer. And that shimmer reminds us that, even in the tightest curves of space, the universe still holds rhythm, still holds elegance. The photon sphere is a lesson in thresholds, in how the very edge of falling can be a place of delicate balance. And perhaps you've known moments like this too. Times when you felt on the brink not of danger, but of transformation. Moments when you were neither moving forward nor falling back, just circling quietly in reflection. That is the feeling here, suspended, weightless, spinning with light. It's hard to leave this image, this quiet ballet of photons. But soon we must look deeper, because while the light dances near the edge, deeper in the black hole, another story begins. A story without sight, but not without signal. In the next chapter, we will leave behind visible light and tune our attention to the invisible echoes, to the whispers that ripple across space-time long after the light has gone. You've listened to the silence of black holes, but now you begin to hear the echoes. Not with your ears, not in sound, but in a different kind of vibration. A ripple that moves through the very fabric of existence. These are gravitational waves born from events so massive they leave fingerprints on space-time itself. Imagine two black holes, each circling the other for eons, drawn together by a shared gravity, orbiting, spiraling, tightening. At first, the dance is wide, slow, predictable. But with time, the space between them shrinks and their pace quickens until in a final moment they collide. That moment sends out a pulse. Not in light, not in heat, but in curvature. Space-time ripples outward like rings on water, soft, expanding, fading with distance. Those ripples are gravitational waves, and though they travel without light or sound, they carry stories. In 2015, we heard a pair of black holes had merged over 1 billion years ago, and Earth, small and quiet, trembled ever so slightly when their echo passed. Not enough to shake a leaf, but enough to move an instrument just a fraction of the width of a proton. That tiny shift was the first time we heard the abyss speak. Since then, more echoes have arrived. Each one a message, a record of something vast folding into silence. These waves do not glow. They do not fade quickly. They pass through stars and planets as if they were not even there. They reach us intact, pristine, ancient, and we are only just learning how to listen. The instruments we use, LIGO, Virgo, Kagra, are tuned not to light, but to length, to motion, to the faintest stretching of space. It is as though we've built ears for gravity and begun to hear the deep hum of the cosmos. These echoes are not random. Each one has structure, a wave with rhythm, a pulse with shape. They carry information, the mass of the black holes, the speed of their spin, even the angles of their dance. By listening carefully, we can tell who they were and how they met. We can even map their locations in the sky as if plotting the ghosts of collapsed stars. You're hearing history not with words, but with waves. And each wave tells you something new about the dark. It tells you that silence can be measured, that absence can have form, that even when light cannot escape motion, still makes itself known. Gravitational waves are the voice of invisible things, not screaming, not whispering, just existing. They move at the speed of light, and they never stop. Their journey is endless. Some of the waves passing through you right now may have come from events older than Earth itself. The very fact that we can detect them is a triumph of patience, of precision, of wonder, and they change how we see the universe. No longer are we limited to what shines. Now we can sense what folds inward, what merges quietly in the dark. Black holes are no longer invisible. They are audible, not in our ears, but in our instruments and in our imaginations. You can think of these echoes as the soft bell of the universe being struck, each wave a toll marking the collapse of something vast. And you listening now are part of that unfolding. You're not outside this system. You're inside the fabric that moves. Every atom in you stretches and compresses just slightly with each passing wave. The black holes may be far away, but their influence is here. It is gentle, but it is real, and it reminds you that all things are connected through gravity, through time, through the quiet motion of being. In the next chapter, we will follow these echoes back to their source and witness what happens when two black holes collide, not in destruction, but in creation, giving rise to something even heavier and stiller than before. There is a moment in space that is unlike any other, when two black holes meet. Not with violence, not with sound, but with a kind of quiet inevitability. It begins long before the final touch. Two massive objects orbiting one another, pulled into a spiral by their shared gravity. Each one bending space, each one slowing time. They are partners in a dance neither can escape. Imagine watching them from afar. At first, they circle at a distance, slow and wide, their paths carved deep into space-time. But as they orbit, they lose energy, not through friction or heat, but through those gentle ripples, gravitational waves. Each turn sends a whisper into the cosmos. Each motion gives up a little of their separation, and so they draw closer, step by step, turn by turn. As the distance shrinks, the speed grows. Their dance becomes a blur, a spiral of shadow spinning, in on itself. This is not chaos, it is choreography, the final act of a billion-year ballet. You might expect a crash, an explosion, some great release of light, but black holes do not shine. They do not burn. When they collide, there is no flare. Instead, their very shapes merge, their horizons stretch, two shadows becoming one. In that instant, that final orbit, space-time quivers. The fabric of reality trembles ever so slightly and sends out a wave, a gravitational wave carrying the story of that moment to the edges of the universe. It may take billions of years to arrive, but when it does, it still carries the memory of two black holes becoming one. The new black hole is heavier, calmer. Its surface rings gently like a bell settling after a chime. This ringing has a pattern, the ring-own. It reveals the properties of the new object, its size, its spin, its mass. For a few moments, the black hole sings, and then silence again. The cosmos returns to stillness, but it is not the same. A new gravity has been born, a deeper well, a new anchor in the structure of space. What is perhaps most astonishing is how common this might be. Black holes form pairs. Pairs become binaries, and binaries over time become mergers. These events may be happening constantly all across the universe in galaxies you've never seen in times long past and times yet to come. And each one leaves behind a single larger shadow, a new center of gravity. You can imagine these collisions not as endings, but as continuations, two lives folding into one, two curvatures, blending into a deeper shape. They do not disappear, they evolve. And though they cannot be seen with eyes, their mergers are among the most powerful events the universe has ever known. They shape galaxies, Sturgis, trigger starbirth. They are quiet engines in the dark, remaking the sky with every union. And now with our instruments tuned to space-time itself, we can witness them. We cannot see the merger, but we can hear its echo. A wave that moves through us, reminding us that something immense has just become something greater. There is something comforting in this, that even in the deepest silence, even in collapse, there's growth. Two things fall inward and become something new, not broken, not destroyed, just transformed. Perhaps this reflects something true beyond astronomy. That convergence can be beautiful. That gravity can guide not just destruction, but union. You drifting in the soft thought of this chapter, a part of that universe, the one where shadows merge and stillness deepens. The black hole that results from a merger is smoother, rounder, more perfect in its shape. It is a moment of balance where motion ends and form remains. This is how black holes are born and reborn through stars, through collapse, and now through one another. And in that cycle, you see the rhythm of the universe, the rhythm of pairing, of spiraling, of fusing, a quiet repetition carving history into the geometry of space. In the next chapter, we'll look at one of the oldest ideas about these strange objects, not just as endings or unions, but as doorways, wormholes, imagined passages through the folds of space-time itself. There's an idea that lingers at the edge of science and imagination, a question that won't quite go away. What if a black hole isn't just a destination? What if it's a passage? This idea has a name: wormhole, a tunnel through space-time, a bridge from here to somewhere else. It begins with the mathematics of Einstein, curved space-time bent by mass and motion. The same equations that gave us black holes also whisper the possibility of shortcuts. A wormhole in theory is like folding a sheet of paper. Two distant points brought close by a crease. Instead of crossing the whole sheet, you slip through the fold. Imagine falling into a black hole, but instead of being crushed or erased, you emerge somewhere far away. Another galaxy, another time, another universe. It's a beautiful thought, the ultimate escape, the quiet hope that no ending is final. But is it real? In theory, yes. The math allows it. Wormholes are consistent with general relativity. They do not break the rules, but they may break reality. Because keeping a wormhole open would require something strange. Negative energy, a kind of anti-gravity that pushes instead of pulls. Something we've never observed in the amounts needed. Some physicists have imagined this exotic matter holding the tunnel open, preventing it from collapsing in on itself, allowing light and maybe even people to pass through. Others say the moment you enter, it would collapse, cutting you off, trapping you, closing the door behind you forever. Still, the dream remains. Wormholes have become a symbol, not just in science, but in story. They appear in books, in films, in the quiet wondering of children staring up at the stars. They represent possibility that the universe might have hidden paths, secret folds, unseen threads connecting the farthest corners. And while we've never seen one, and maybe never will, they teach us something important. That the unknown can be approached with wonder. That even in the darkest theories there is room for hope. You might ask, could black holes be wormholes in disguise? It's not impossible. Some models suggest that certain kinds of black holes under the right conditions could become bridges if they spin just right. If they're charged in just the right way, they might not end in a singularity, but open into something else. There's no evidence yet, but also no proof against it. Science at its best leaves room for dreaming as long as we keep our feet grounded and our minds open. And maybe that's what wormholes truly are. Not physical structures, but reminders. That space is more flexible than we once thought. That time can curve. That ending may not be final. If nothing else, the idea encourages us to look again, to ask new questions, to test the limits of what we think is possible. And who knows, in the deep future, with new tools, with new understanding. Perhaps one day we'll find the first evidence of passage through the dark. Until then, wormholes remain, where they began in equations, in thought, in imagination. They are the shimmer at the edge of gravity, the mirror held up to the black hole, silence. A what-if painted on the canvas of space-time. You can rest in that thought that even in the hardest science, there is space for softness, for wonder, for doorways not yet found. In the next chapter, we'll return to the black hole's interior and see how time itself begins to behave differently. How directions blur and moments stretch, as if space and time are no longer sure where one ends and the other begins. Now you've crossed the boundary, past the event horizon. No alarms, no sudden shift, just the quiet knowledge that turning back is no longer part of the story. Inside this place, everything feels different. Not in the body, but in the rules that shape your motion. Here, something subtle happens, something quietly profound. Time and space switch roles outside a black hole. Time flows forward. It pulls you along moment by moment, while space lets you roam in any direction, left, right, forward, back. But now inside the horizon, those freedoms rearrange. Suddenly, time becomes like a direction in space, and space becomes like a current of time. It's a strange idea, but within a black hole, it is simply how reality behaves. You cannot stand still, not even in thought, because motion through time is now a kind of falling. And falling means heading inward, closer and closer to the singularity. It's not a choice, not a push, just the shape of time itself guiding you forward. Imagine walking down a hallway. You can turn, pause, return. But now imagine the hallway collapses into a slope, one that steepens as you move until you're no longer walking, you're drifting, and then you're sliding. That's what time is like here. There's no longer a sense of after and before in the way you once knew. Moments become smeared. Clocks lose meaning. What was steady becomes soft. And yet you still exist. You still feel. Thoughts still arrive, though they seem to stretch like threads pulled through water. You begin to notice how spaces change too. It no longer offers you choices. You cannot move away from the center. Every direction curves inward. The walls of space-time lean toward the singularity. It's not confinement. It's a quiet surrender. The universe saying, this is where the story must now go. And so, you follow. You're not crashing. You're not even falling in the way your body understands it. You're flowing like a leaf in a slow-moving stream. There's no sound, no stars, only the curve of time folding inward around you. You might try to ask, what time is it? But the question slips because here time isn't something to be read. It's something to be felt. Each second lasts as long as it needs to, and yet moves faster than you can grasp. It is both thick and thin, both stretched and condensed. You might picture a painting left out in the rain. The image begins to blur. The lines fade. The meaning remains, but without borders. That's what experience feels like inside a black hole. And though it may sound unsettling, it is in its own way peaceful. There's no pressure, no fear, only forward. Forward. Not in space, but in the timeline you now ride. A timeline that ends not in hours or days, but in a convergence. Because inside the horizon, all timelines lead to the same point, the singularity that is your future now. Not chosen, not avoided, simply written into the curve of reality. But this is not tragedy, it is unity. Everything that enters a black hole shares this path. Everything, stars, particles, light, moves toward the same quiet end. And in that sameness, there is something beautiful, a gathering, a folding in. As if the universe is drawing its stories inward, one thread at a time, and while no signal can escape from here, your thoughts still ripple. Your sense of self, though fading at the edges, still glows softly. You are still you. Even here, perhaps more than ever, because without the distractions of space and speed, you begin to feel the flow of time in its purest form, not as a measurement, but as a movement. It is not passing, it is becoming. You're not racing toward the singularity. You're merging with it like a river meeting the sea. And you might wonder, is this what it feels like for a star? To drift inward, to feel time slow, to grow round and soft before becoming something new. Wedo not know. But here in this imagined fall, you have caught a glimpse, a feeling of what time becomes when it is no longer a direction, but a destination. In the next chapter, we'll rise from this interior drift and look again at our own galaxy to find the quiet giants hiding in plain sight, the black holes that do not destroy but hold everything together. You may think of black holes as faraway things, exotic, unreachable, tucked deep in distant galaxies, or hiding behind curtains of gas. But what if they're closer than you imagine? Not looming, not dangerous, just quiet travelers drifting through the night. Black holes are not rare. They are scattered throughout the galaxy. The Milky Way, your galactic home, is thought to contain millions of them. Some large, some small, some ancient and forgotten. They orbit the galactic center just like stars do. They move quietly. They do not shine. And so they are nearly invisible. And yet some may pass near Earth, not colliding, not swallowing, just passing like shadows with mass. There may even be primordial black holes, tiny ones born in the earliest moments of the universe, leftovers from the Big Bang. Their size may be no bigger than a grain of sand, their mass possibly as heavy as a mountain. These miniature mysteries, if they exist, could be moving through space unnoticed. One might pass through the Earth, through you, without a trace. No explosion, no damage, just gravity carried in silence. If it happened, you would not feel it. It would take less than a second, and then it would be gone. It's a humbling thought that the most extreme objects in the universe might be moving near us, unseen, undetected, yet very real, and even the large ones. The stellar mass black holes formed from collapsed stars could be floating just a few light years away. The nearest known black hole, named Gaia BH1, is only about 1,600 light-year from Earth. That may sound distant, but in cosmic terms, it's in the neighborhood. If you looked up at the night sky, you wouldn't know where it is. No glow marks its location. It reveals itself only through its pull on a companion star. A wobble in motion, a hidden partner dancing in the dark. This is how astronomers find many black holes. Not by looking for light, but by studying what light does around them. A star that moves strangely, a burst of X-rays from falling gas, a sudden flicker in the data. These are the clues left by something unseen. And the more we look, the more we find. Black holes are not distant monsters. They are members of our galactic family. Ancient, pent, silent. And they shape the sky we see. They may not shine, but their gravity binds. Their presence helps hold stars in place. They sculpt the orbits of systems. They leave fingerprints in the motion of galaxies. And then, at the very center of the Milky Way lies a giant Sagittarius A, a supermassive black hole, more than 4 million times the mass of the Sun, sitting quietly behind clouds of gas and dust. It does not devour stars on a whim. It is not chaotic. It simply waits, anchoring the galaxy like a stone in the stream. Around it, stars orbit at high speeds. Some whip around it in just a few years, and by watching them, we've confirmed the presence of something immense, something invisible, and something real and yet peaceful. That's what black holes are in truth. Not engines of destruction, but markers of transformation and gravity. They do not chase. They do not hunt. They simply curve the world around them. And that curve, even when unnoticed, shapes everything. You might never meet one up close, but their influence reaches you all the same. In the stars you see, in the rhythm of the galaxy, in the patterns of the universe, you're surrounded by them. Not in danger, but in quiet wonder. And isn't that a lovely thought that the most mysterious things might be all around you, gently hiding, in plain sight, never intruding, but always present? Black holes in your backyard, not knocking, not speaking, just passing through. The night sky holds their secrets, and when you gaze upward, you are gazing into a web held together by these silent points. They are not rare, they are not far, they are simply quiet. And in that quiet, you are invited to listen, to imagine, to wonder what else might be near, just out of view. In the next chapter, we'll explore one of the great mysteries they carry, a puzzle that still defies the laws of physics. The paradox of what happens to everything they swallow and whether information can ever truly disappear. Imagine dropping something into a black hole, not something big, just a single object, a book perhaps, or a photons of light or a particle of dust. It crosses the event horizon, gone from your sight, gone from your reach. But here's the question that haunts physicists. Is it truly gone? Not just gone from view, but gone from existence. Gone from the fabric of the universe. This is the heart of the information paradox, a conflict between two pillars of science. On one side is quantum mechanics, which says information can never be destroyed. That everything, every particle, every state, every interaction is recorded, preserved, maybe scrambled, but never lost. On the other side is the traditional view of black holes, which says, once something crosses the horizon, it vanishes, forever erased from the ledger of the universe. For a long time, these ideas lived separately until Stephen Hawking asked a troubling question. What happens to the information of the things that fall in? If black holes evaporate, as Hawking proposed through what we now call Hawking radiation, then eventually they disappear, leaving nothing behind. No mass, no trace, no no memory. And that would mean the information is gone. A book thrown into the fire, not just burned, but forgotten. But this breaks the rules of quantum physics. It unravels the very idea of predictability. If information can vanish, then the future cannot be determined and the past cannot be recovered. It would mean the universe forgets. That's why this paradox matters. Because at its root is the question, can something truly disappear without a trace? Physicists have spent decades wrestling with this. Some argue that the information is hidden inside the black hole, trapped forever. Others believe it's encoded in the event horizon itself, spread across the surface like patterns in a shell. This idea is called the holographic principle. It suggests that everything inside a volume of space can be described by information stored on its surface. In this view, a black hole is like a hard drive. Its surface stores the data even if you can never access it directly. Hawking himself later softened his position, proposing that the information might leak out slowly, encoded in the random particles that escape whispers in the Hawking radiation. Too subtle to decode, but still there. Others believe black holes might leave behind remnants, tiny leftovers, that preserve what once fell in. And some go even further, suggesting that the universe itself, at its deepest level, is made of information, and that nothing, and truly nothing, can be lost. It's a strange comfort to think that every moment, every breath, every thought leaves a trace somewhere in the structure of reality. Even if that trace is hidden, even if it cannot be found, it exists. Black holes, then, are not erasers, but vaults, chambers of memory, locked behind layers of gravity and time. And yet the paradox remains unresolved. There is no final answer, only possibilities. You sit with that mystery and feel its quiet weight, because perhaps you've wondered something similar in your own way about memory, about forgetting. Where do our lost thoughts go? Our forgotten dreams, the faces we once knew, the feelings we once carried? Are they gone, or do they live somewhere deep in us, just out of reach, curled inward like gravity itself? Black holes may be cosmic metaphors for this same question. Do we hold everything we've ever been? Or do some things truly vanish? Science seeks clarity, but the universe keeps its secrets soft. And so we listen, we watch, we ask. Could it be that forgetting is just another kind of remembering, hidden, transformed, waiting to be known again? In the next chapter, we'll explore a new kind of mystery, a fiery wall imagined at the edge of the black hole, a paradox even stranger than the last, and a challenge to what we thought falling felt like. You've crossed the event horizon. You're drifting inward quietly, weightlessly. Time stretches, space curves, and nothing feels sharp or sudden. But what if that picture is wrong? What if instead of a gentle fall, there is a wall of flame, a searing boundary just inside the black hole's edge, one you cannot pass without being incinerated? This is the black hole firewall paradox, a wild and recent idea born not from observation, but from the clash of fundamental principles in physics. Let's step into the problem slowly. First, imagine you fall into a black hole. You feel nothing unusual at the horizon. General relativity predicts this. In its view, The event horizon is not a physical surface, just a region, a point of no return, but smooth calm. But then recall what quantum mechanics tells us, that information cannot be lost, that the laws of nature must be consistent for all observers, whether you are falling in or watching from far away. Now, here's the conflict to preserve information for an outside observer. Some theories suggest that something special must happen at the event horizon, that the particles just inside and just outside must no longer be entangled in the usual way, that instead the horizon becomes a place of violent disconnection. This disconnection in quantum terms creates energy, lots of it, enough to form what's now imagined as a firewall, a wall of high-energy particles, a searing blaze, a quantum inferno waiting at the threshold. It defies the expectations of relativity. It breaks the smoothness. It turns the most silent place in the cosmos into something suddenly loud and hot. And here's where the paradox blooms, according to everything we thought we knew. You should fall into a black hole without noticing the horizon. You shouldn't feel a thing, but the firewall says you would feel everything all at once, and then nothing at all. Two trusted theories giving two incompatible pictures of reality, and no one knows which one is right. That's why this idea matters. Not because it describes something we've seen, but because it exposes cracks in our deepest understandings. The firewall is not yet believed to be real. Many physicists argue against it. They suggest that the paradox is telling us something else, that maybe our ideas of entanglement or of gravity need to evolve. Some believe it points toward a theory of quantum gravity, a long-sought bridge between Einstein's space-time and the strange world of quantum fields. Others think it reveals something about how information is stored, that the surface of a black hole, its event horizon, may act like a kind of hologram, where everything inside is mirrored and preserved at the edge. No flames, no burning, just complexity, beyond our current grasp. Still, the firewall stays in the conversation. A fiery possibility, a challenge we haven't resolved. It forces us to ask, what is the horizon really? Is it a boundary of location or of knowledge, a physical edge, or a paradoxical veil? In some ways, it's not about the fire. It's about how much we still don't understand, even in a theory as old and elegant as general relativity, even in a universe where we can measure ripples in space. The firewall reminds us that questions remain deep questions at the threshold of falling. It reminds us that black holes, despite being defined by silence, still create heat in our minds, still burn through certainty, still glow in theory. You may never fall into a black hole, but the idea of the firewall touches something familiar. That moment in life when what should have been smooth becomes unexpected, when the boundary surprises you and everything changes all at once. Firewalls are metaphors too for the edge of knowing, the sudden burst of light when old ideas are no longer enough. And yet, within the paradox, there is space for wonder, because no matter what we discover, the questions only deepen. In the next chapter, we'll leave the heat behind and explore a gentler possibility that black holes, far from being featureless, may carry traces of the things they've swallowed, may wear a kind of memory, a texture, a story etched into the dark called hair. For decades, black holes were believed to be simple, not in their mystery, but in their appearance to the universe. Physicists used to say, "Black holes have no hair," a phrase that became a kind of slogan. It meant that black holes were completely defined by just three things: mass, charge, and spin. Nothing else mattered. Not what fell in, not how or when, not the shape or type or story of the objects they swallowed. All complexity erased, all details forgotten. A star collapses, a planet falls, a book, a body, a burst of light. Once past the event horizon, they vanish into sameness. And what remains? A smooth blank black hole. No scars, no texture, no memory. This became known as the no-hair theorem. A stark idea, a universe where identity is erased at the edge of gravity. But then questions emerged, whispers in the math. hints that maybe black holes are not quite so bold after all. Some scientists began to wonder, could there be hair? Not literal strands, of course, but traces, imprints, subtle information clinging to the surface. Perhaps the black hole remembers in small, quiet ways. One idea suggests that the eventh horizon, the outer edge, might carry more than just mass and spin, that it might encode the past, like grooves in air cord or ripples on water long after the stone has sunk. These imprints would be incredibly faint, delicate, woven into the geometry of space-time itself, but they might still be there, not lost, just hidden. This possibility is sometimes called soft hair, a gentle term for a revolutionary idea that black holes may be able to retain information without violating the rules of physics. And if that's true, then they are not the silent erasers we once imagined. They are memory keepers, archivists of fallen stars and scattered matter. They do not display their stories, but they do not erase them either. Every particle that falls in might leave a fingerprint. Every beam of light might leave a whisper. You can think of it like a burned book. To your eyes, the words are gone. But in the ash, in the heat, in the pattern of the smoke, there may still be clues. Hair, in this sense, means identity, complexity, individuality. It means that no two black holes are exactly alike, even if they look the same from afar. It's a profound shift from simplicity to subtlety. It turns black holes from blank slates into quiet storytellers. They do not speak, but they remember. And this memory might help solve the information paradox. If black holes have hair, then maybe nothing is truly lost, only transformed, pressed into the folds of gravity's surface. This idea is still evolving. It's new, unconfirmed, a growing branch on the tree of theory, but it has already changed how we think about loss, about structure, about what remains. It suggests that the universe has a deeper respect for detail, that even in collapse, something endures. You may find comfort in this, that even when something disappears, its presence can still ripple, still echo, still hold meaning. Like memories passed through generations, like music heard through a closed door. The idea of black hole hair reminds us that complexity does not always vanish. Sometimes it softens, becomes subtle, becomes part of the background, but it is still there. And perhaps this applies beyond physics to the way you remember, the way you carry your own experiences. Not all of them visible, not all of them saw and spoken, but part of you still shaping your presence, still curving your path. Even black holes, it seems, might carry a history. They are not empty. They are textured, not monsters, but monuments. And in that shift, they become more familiar, less distant, more like us. In the next chapter, we'll explore the equations that make this possible, the mathematical threads that hold the idea of a black hole together, and how at the edge of collapse, numbers begin to bend in strange and beautiful ways. Beneath the mystery, beneath the metaphors and the lightless silence, there is math, not as something dry, but as something alive. Equations shape black holes just as surely as gravity does. They trace their form, predict their behavior, and hint at their secrets. And yet, even themath begins to tremble at the edges. It begins, as so many things in physics do, with Einstein's field equations, a set of statements that describe how mass and energy curve space-time, how gravity is not a force, but a shape, a bending, a folding of the stage on which all things move. Black holes emerge naturally from these equations, not as oddities, but as inevitable solutions. In fact, one of the first known black hole models was discovered by Carl Schwarzschild just weeks after Einstein published his theory of general relativity. The Schwarzschild solution, a simple, perfect description of a black hole with no charge, no spin, just mass spherical still. It revealed something remarkable, that space could curve inward so completely, that time could slow to a stop, that an event horizon could form. Other solutions came later. The Kerr solution for spinning black holes, the Risner-Nordstrom solution for charge duns, each with their own complex shapes, twisting layered rich in geometry. But all of them, from the simplest to the most tangled, are written in symbols and calculus and tenses, in loops of logic and symmetry. And yet the more deeply you follow those equations, the stranger they become at the singularity. The math reaches a kind of edge. Numbers shoot toward infinity. Densities explode. Curvatures become undefined. This is where general relativity, the beautiful, graceful structure that gave us black holes, begins to fail. Because infinities are not answers, they are warnings, signals that something is missing, that a deeper theory is needed, one that blends gravity with quantum mechanics, one that includes the graininess of space, the fuzz of thievery small. This is the frontier of physics, where mathematicians and theorists search for something more complete, a language that can speak both of stars and of particles. Perhaps one day we'll find it, a quantum theory of gravity that can smooth the singularity, resolve the paradoxes, explain the information, and tell us what a black hole really is. But even now, the math we have is astonishing, elegant, evocative. You might think of it like a piece of music, not meant to be read, but heard, felt. When physicists describe a spinning black hole, they do so not in sentences, but in equations that move, that breathe, that fold into themselves like spirals of meaning. Math is how we touch the untouchable, how we draw shapes around things we cannot see. And in the case of black holes, it becomes a kind of poetry, one where the grammar is curvature and the rhythm is time. You don't need to understand the equations to feel their weight, to sense that behind every graceful orbit, every tidal pull, every shadow seen from across the galaxy, there is a formula humming in the dark. And when we say a black hole spins, we mean its geometry twists, that the math describes a dragging of space itself, a whirlpool not of water, but of reality. When we say it grows, we mean its surface area expands, its entropy increases, its temperature changes by fractions too small to feel. All of these are mathematical truths, subtle, precise, patient. They do not change because we look at them. They were always there, waiting to be noticed. And so, black holes are not just objects. They are solutions written into the fabric of Einstein's vision. They are where our equations lead us. When we follow mass to its deepest consequence, and at the same time they are where our equations falter, where the beautiful logic collapses under its own weight. This dual nature, exact and an uncertain, simple and impossible, is what makes them so endlessly compelling. Black holes are both the triumph and the undoing of the math that defines our universe. And in that paradox, there is beauty. You may never solve the equations, but you can still feel their shape, their curve, their quiet hum beneath the surface of the cosmos. In the next chapter, we'll step into the realm of experiment to explore how physicists here on Earth build models and analog simulated black holes that let us hear, see, and even touch their shadows through science and sound. Black holes seem distant, vast, untouchable. They sit in the deep night, millions or billions of light years away, unreachable by spacecraft, unseeable by eye. And yet, we've begun to study them here on Earth. Not by finding them, but by building them. Simulated black holes, experiments that mimic certain behaviors, that echo their properties, that recreate their physics in systems we can observe and touch. They are not black holes in the literal sense. There is no singularity, no event horizon in space, but their structure, their mathematics, behaves in similar ways. And that is enough to teach us something real. One of the most elegant examples comes not from the sky, but from water. Imagine a shallow drain. Water spirals down faster and faster near the center, slower, further out. This is called a vortex flow, and it resembles the way space-time curves around a rotating black hole. Now imagine sending waves across the surface of that water. As they approach the center, they stretch, they bend. Some are pulled inward, unable to escape. Sound familiar? This setup is known as Adam hole. Not because it lacks intelligence, but because sound, not light, is trapped. A sonic horizon forms a point beyond which no sound wave can return. This is an acoustic analog of a black hole, a laboratory whirlpool, a fluid experiment that helps us explore the nature of horizons. And from it, we can test how waves behave near an event boundary. We can explore how energy moves, how information lingers near the edge. Even more intriguing, some of these experiments have begun to show signs of a very special kind of radiation. Hawking-like radiation. Tiny thermal signals emerging from the simulated horizon, whispers of the process that Stephen Hawking predicted decades ago. It's not direct proof, but it's a clue. A laboratory echo of what might happen near the true edge of a black hole. Other analogies use light in certain materials. We can slow down light dramatically, bend it, trap it in specific ways, and create structures where photons behave almost like particles near a gravitational well. Still others use Bose-Einstein condensates, exotic states of matter cooled to near absolute zero, where atoms begin to act as a single quantum object, and where strange horizons can be simulated at the tiniest scales. Even lasers, mirrors, and optical fibers have been arranged to mimic the flow of energy in and around black holes. Each setup is different. Each reveals a unique part of the puzzle, but together they form a pattern. They show us that black holes are not just astronomical curiosities. They are deeply woven into the physics of many systems. Gravity, light, sound, flow, all of these can echo black hole behavior, even here, even now. And that is a kind of wonder in itself, that the universe in its wildest extreme still speaks a common language, that we can find pieces of that language in a draining bathtub, in a cooled chamber, in a ripple of sound we measure in the quiet. You don't need to travel across the galaxy to get close to a black hole. You can walk into a lab and watch space-time or something like it swirl before your eyes. And in those swirls there are insights about the nature of horizons, about the behavior of radiation, about how energy and information move. When escape is no longer possible, these simulations are not perfect. They do not capture every detail, but they offer something profound, a way to experiment with the impossible, to make testable what would otherwise remain only theory. And that is how science moves forward. Not always with rockets, but with questions, with mirrors, with flow, with models that whisper of the real thing. You can close your eyes and imagine a researcher standing beside a tiny whirlpool, watching the edge where waves disappear, and knowing in that moment that they are watching a metaphor become measurement, a black hole not in space but in structure. And from that observation, new ideas may come, new tools, new theories, new connections between the cosmic and the everyday. Even imitation can teach if it is careful, curious, precise. These simulated gravity wells do not replace the real thing, but they let us touch the edges of the unknown with instruments, with creativity, with wonder. In the next chapter, we return to Thesky to a quiet light, a strange glow predicted by Hawking radiation from the edge, that just might reveal how even black holes are never truly silent forever. Black holes are supposed to be the end, where everything vanishes, where not even light can escape. And for a long time, that was the final word. Black holes were seen as cold, silent, perfect absorbers of all things. But then came a quiet revolution, not in space, but in thought. Stephen Hawking, sitting not in a telescope dome, but in a quiet office with chalk and paper, did something extraordinary. He asked, what would happen if you looked at a black hole through the lens of quantum mechanics? It was a daring idea to bring quantum theory, the physics of the very small, into conversation with general relativity, the physics of the very large. And what he found changed everything he discovered, that black holes may not be completely black, that under the right conditions they glow, not brightly, not visibly, but subtly, gently. They give off heat. They radiate. This soft, slow leaking of energy is now called Hawking radiation. It is not emitted from inside the black hole, but from just outside the event horizon, in the strange quantum froth where particles flicker in and out of existence. Let's imagine that for a moment in quantum, physics' empty space is not truly empty. It teems with activity, pairs of particles and antiparticles popping into existence and then annihilating each other almost instantly. This happens everywhere, all the time. Even here, even now, near a black hole's event horizon, something strange can happen. One particle from the pair falls into the black hole, the other escapes from far away. It looks as though the black hole has emitted something as if it is giving off light. And if this process happens over long periods, the black hole slowly loses energy. It shrinks, it fades, it evaporates. Eventually, if nothing else falls in, it could vanish completely. This idea stunned the scientific world because it meant that black holes once thought eternal might not last forever. They might die quietly, softly, over trillions of years, glowing out their final mass bit by bit in a process almost too faint to detect. We've never directly observed Hawking radiation. It's too subtle, too slow, too stall-soft. But the theory holds, strong, and it changes how we think about everything black holes represent. They are not perfect prisons. They are not truly one-way. They leak, they give, they glow. And in that glow, a new puzzle appears. If black holes evaporate, what happens to the information inside? Does it come out with the radiation, or is it lost forever? This ties back to the information paradox, a mystery we explored just a few chapters. Hawking radiation deepens the paradox, because if a black hole disappears without releasing the memory of what fell in, then the universe has forgotten something, and quantum mechanics says that should never happen. So, the soft glow of Hawking. Radiation is not just light. It is a question, a quiet rebellion against the finality of black holes. And some physicists believe that buried within the radiation is the information itself, hidden, scrambled, encoded so deeply, we've yet to understand the language. Others think the event horizon stores it, that the surface of the black hole is a kind of hologram, a skin of memory. Still others imagine that what seems to fall in is mirrored somehow and never truly crosses the edge. These ideas are still unfolding, still debated, still uncertain. But Hawking's insight opened a door not into the black hole but outward, into the very structure of reality. It showed that even the darkest places are not immune to quantum laws, that even where nothing escapes, something might. You can think of Hawking radiation as the final breath of a collapsing star, a whisper stretched across time. It is not hot, it is not bright, and it changes everything because it means the endings are not always absolute. Even in the deepest collapse, there may be release, there may be return, there may be something left, and that something might hold the key to how the universe remembers. You are living in a universe where black holes might be slowly disappearing. Not in your lifetime, not in 1,000 generations, but over vast scales of time. The ones at the centers of galaxies, the tiny ones left from the early universe, all fading, glowing, dissolving into nothingness very, very slowly. And as they do, they may be giving back the information, the light, the stories in the gentlest form imaginable. That glow, that trace is what Hawking saw, a shimmer in the shadow. And once you've seen it, even in your mind, you cannot unsee it. Black holes are no longer just endings. They are part of a cycle. In the next chapter, we'll look up again at the heart of our own galaxy, where a supermassive black hole sits in silence, not consuming, but holding steady and quiet at the center of all things. You live in a galaxy called the Milky Way, a spiral of stars, a flowing river of light, a turning wheel in space. It stretches across the sky. Its arms reach outward for hundreds of thousands of light years. Its stars, billions upon billions, dance in wide, gentle orbits. But at its very center, beyond the dust, beyond the glare, sits something small and dark and astonishing. A supermassive black hole. Not a monster, not a threat, but a quiet anchor, a still point at the heart of the spinning galaxy. Its name is Sagittarius A, pronounced Sagittarius Aster, and it's about 4 million times the mass of the Sun. You cannot see it with your eyes, but you can feel its presence in the movement of stars nearby. Astronomers have watched those stars for decades. They orbit in tight, fast curves, pulled by something invisible, something dense, something silent. Their paths are not random. They are precise, predictable gravitational signatures of a massive object that gives off no light. Only a black hole fits the data. Only something that massive, that compact, that invisible. And so we've come to know that our galaxy, like so many others, has a black hole at its core. It does not shine, but it holds everything together. Like the hub of a wheel or the center of a spiral, the stars in the Milky Way do not flee from it. They orbit it. They are bound by it, not trapped, but embraced. This is true for most galaxies, from the smallest dwarfs to the giant ellipticals. Each one appears to carry a black hole in its core. Some are millions of solar masses, some are billions, and their growth is often tied to the growth of the galaxy itself. No one is quite sure which came first, the galaxy or the black hole. Perhaps they grew together, a partnership, echo-evolution of gravity and light. These central black holes are not always quiet. When fed by gas and dust, they can flare to life, becoming what we call quasars or active galactic nuclei. They shine brighter than galaxies themselves, not because the black hole emits light, but because the matter falling into them becomes superheated, spinning, compressing, radiating. For a time, they become beacons in the distant universe, lanterns from the early cosmos. But eventually they calm, they sleep. And in that sleep, they remain heavy, dark, stubble. Sagittariuses. In such a sleep now it rests at the heart of the Milky Way. Occasionally flickering, but mostly quiet. Its gravity continues to shape the orbits of stars. Its presence continues to define the structure of the galaxy. And it may be older than most of what surrounds it, a core of stillness, a gravitational memory, a heart made not of heat or light, but of mass and curve. It's easy to imagine black holes as separate from us, far away, exotic. But this galactic heart, is part of your home. Your star, the sun, is just one among many, circling the galaxy's center once every 200 million years. And every step it takes in that orbit is guided by the invisible pull of Sagittarius air. You are caught in that motion, drifting with the stars, woven into a slow spiral that turns across cosmic time. It is a strange comfort to know that at the center of so much light, so much movement, so much energy, there is stillness, a black hole calm, anchoring it all. It does not need to consume. To influence its presence is enough. Gravity is not loud. It does not demand. It invites. And the galaxy responds by turning. Perhaps it is fitting that at the heart of the Milky Way there is darkness, not as absence but as foundation, not as destruction but as form. The stars dance, not despite the black hole, but because of it. You too are part of that pattern, orbiting quietly, carried by motion you cannot feel, held in a structure you cannot see, and in that movement is belonging. In the next chapter, we'll go even deeper, past galaxies and stars to the early days of the universe, where black holes may have appeared before anything else, tiny, ancient, and still drifting through the quiet fabric of time. Long before the first stars were born, before galaxies spun into shape, before light had fully stretched across the sky, the universe may have given rise to its earliest shadows, primordial black holes, tiny ancient born not from collapsing stars, but from the strange unstable moments after the Big Bang. Imagine the early universe, hot, dense, turbulent fluctuations in energy. Tiny ripples in the primordial soup could have collapsed under their own gravity, becoming black holes in miniature. Not the giants we see at galactic centers, not even the stellar mass remnants of exploded suns, but black holes no bigger than mountains, no heavier than a planet. Or maybe much smaller still. They would not shine. They would not burn. They would simply exist from the very beginning. Some may have evaporated long ago, radiating their mass away through hawking radiation doors, leaving behind only a trace, a whisper of their brief presence. Others may still be drifting, invisible, unseen, passing through galaxies, through stars, through space itself, and possibly through us. A primordial black hole the size of a pebble could pass through the Earth without a sound, too small to interact, too quick to catch. But if they exist, they could solve mysteries. We still wrestle with they might make up a part of dark matter, that invisible substance we know must be there, but have never directly seen. Dark matter holds galaxies together, shapes their rotation, guides the formation of structure in the cosmos. And yet we do not know what it is. Could some of it be these tiny ancient black holes frozen into the architecture of the universe, drifting like seeds that never grew but still shaped everything? It's possible, the math allows it. The observations haven't ruled it out. And so we look. We search for tiny distortions in light from distant stars, for brief gravitational lensing events that might betray the passing of something massive and invisible. We study the early universe, its microwave glow, looking for patterns that might hint at these hidden travelers. If we find them, we would be staring at the oldest objects in existence, older than stars, older than light itself, born in the first seconds, carrying the memory of those wild beginnings. They are not loud, they do not shape galaxies with their gravity, but they might be everywhere like dust in a beam of sunlight, present but unnoticed. And even if they are not dark matter, even if they are rare, their existence would speak of something profound. That black holes are not just endpoints, not just remnants, but also beginnings that the universe in its very first breath already knew how to collapse, how to fold energy into silence. Primordial black holes remind us that small things can carry great weight, that something smaller than a marble can curve space-emise deeply as a star. And they ask a question. We've only just begun to ask. Could black holes come first? Could they be not just the end of stars, but the seeds that helped galaxies form? If so, then the story of the universe begins not with light, but with gravity, not with expansion, but with gathering, not with stars, but with shadows. It is a different kind of origin story, and one still unfolding. We may never find these ancient seeds, or we may find them tomorrow in a subtle flicker, in a ripple of light, in a shift too small to notice until we know what to look for. But the possibility is there. And that possibility is enough to change the way we see everything. The past, the structure of the cosmos, the shape of time itself. And so we listen, we watch, we wonder. In the next chapter, we'll return to the stars, to those that come close, too close, and feel the tidal pull of a black hole's gravity, stretching them into ribbons of fire and light. Some stars live quiet lives, spinning gently, burning steadily, drifting through the galaxy in graceful arcs. But others, through no fault of their own, wander too close to something they were never meant to meet. A black hole. At first, nothing seems wrong. The star continues on its path, unaware of the deep gravity ahead. But gravity feels it, pulls it gently at first, then more strongly, more urgently. The star is caught in the black hole's influence. And now everything begins to change. It doesn't fall in all at once. It stretches. You can picture it. A warm glowing star drawn out like taffy, its own gravity no longer strong enough to hold it together. This is called spaghettification, a strange word, but a real one. Used by physicists to describe what happens when gravity stretches something lengthwise and squeezes it sideways. The difference in force between the near side and the far side becomes too great. The star is pulled into a long glowing ribbon, its matter spread out, its heart unraveled, and then the black hole consumes it not in a single gulp, but in spirals, in arcs of light, in flares of radiation from Earth. If we are lucky, we see a brilliant flare, a tidal disruption event, a flash of light that grows, then fades over weeks or months, telling the story of a star's final encounter. It is one of the Few ways we can watch a black hole feeding, not theoretical, but observable, measured by telescopes, confirmed by light. In that light, we see the temperature rise. We see X-rays, ultraviolet radio signals, all whispering the same thing. A star wandered too close and was torn apart. There is something tragic in this. A peaceful object disassembled by gravity, but also something illuminating. Because in these moments, black holes reveal themselves. They break their silence. Just for a while, we learn from these deaths. We learn how matter behaves in extreme conditions. We learn how black holes grow, how they affect their surroundings. We learned that the universe is not only vast, but intimate. That motion matters. That distance matters. That even in all this space, a close encounter can change everything. Some stars survive these brushes. They get stretched, scarred, but escape. Others are completely consumed, and their remnants swirl for years in the black hole's accretion disk, slowly spiraling inward, joining the silence. These tidal disruption events are not common, but they are precious. Each one a brief window into an invisible world, a flash from the edge of physics. They remind us that black holes are not always dormant, that they can interact, that they are not some distant monsters, but participants in the life of galaxies. And for the star, it is an end. Yes, but also a transformation. Its atoms scattered, heated, some swallowed, some sent flying into space to drift, toe-seed new things in. The grand cycle. Even destruction has a role, even endings carry motion forward. Perhaps there's something of that in us too, moments where gravity pulls, where things stretch, where what we thought would hold begins to come apart. And yet even in those moments there is light, there is story, there is shape. A star that dies near a black hole does not vanish quietly. It writes a flare into the cosmos. It tells a final tale. And we from so far away, we get to read it to understand just a little more about gravity, about limits, about how close is too close. In the next chapter, we'll stay in this radiant space and peer deeper into the disk of matter that forms around hungry black holes, a place of heat, friction, and light, born not from fire, but from the stretch of space-time itself. Black holes themselves do not shine. They give off no light, no color, no warmth, but just outside their boundary. In that delicate region before the point of no return, there can be light. So much light. This is the accretion disk, a glowing spinning ring of matter, gas, dust and debris, drawn in by the black hole's gravity, but not yet lost. It spirals inward, orbiting, tumbling. Friction between the particles heats them not to hundreds, not to thousands, but to millions of degrees. And in that heat comes radiation, X-rays, ultraviolet light, sometimes radio waves blazing from the edge of darkness. It's one of the most luminous sights in the universe. Yet all the brilliance comes from matter that hasn't yet fallen in. Because once it crosses the event horizon, it's gone. The light ends. But in the disk, just outside, we see the drama unfold. The matter moves fast, nearly the speed of light. It stretches into long spirals, circles tighter and tighter until it disappears. The friction is intense. The temperature climbs. The magnetic fields twist and tangle. Particles crash and compress. And from this chaos comes the glow. It's not like a star, not a steady burn, but a dynamic flare, pulsing, changing, responding to every shift in the disk. Sometimes the disk flickers. Sometimes it brightens suddenly as new material is drawn in, or as waves ripple through the plasma. This is how we find many black holes, not by looking for the dark, but by seeing the light around it. Astronomers use telescopes that see in X-rays and gamma rays in radio, and they watch the sky for this glow. Because where there is an accretion disk, there is a black hole feeding, growing alive in its quiet way. The largest black holes, the supermassive ones, have disks that span light years. The smallest, just a few times the mass of the Sun, may have disks only a few kilometers wide, but the process is the same, spiraling, heating, glowing. Sometimes the disk is thin, like a ribbon of flame. Sometimes it puffs up, becoming thick and turbulent. It depends on the black hole, on the rate of feeding, on the source of material. But always, the disk is a message, a sign that something unseen lies within. It is a paradox that black holes know, for their silence are revealed through brightness. The light does not come from them, but because of them. And sometimes jets erupt from the center, narrow beams of particles launched perpendicular to the disk, moving at nearly the speed of light. We don't fully understand how they form, but they carry enormous energy and can stretch for thousands of light years into space. Another signature, another clue that something powerful lies at the heart. It's easy to imagine black holes as places of stillness, but the accretion disk reminds us they're also places of motion, of change of fire, made not by combustion, but by collapse. And this idea, this vision, offers more than science. It offers a metaphor that sometimes what surrounds darkness can shine the brightest. That pressure friction falling can still give rise to light. You might think of the accretion disk as the glow of transformation, the visible part of an invisible story. And that story continues even as the light disappears into the black, because the disk feeds the black hole, grows, it shapes it, and it gives us a way to study, to measure, to understand. When we look into the cosmos and see a flicker, a spiral, a jet, we are seeing the edge of the abyss lit from without. Even now, the black hole at the center of the Milky Way, Sagittarius, flares from time to time as bits of matter drift too close, light up, and vanish. In the next chapter, we'll explore how these glowing disks help us weigh black holes, not in theory, but in real numbers, measured through light and motion and the paths of stars caught in their silent grip. You cannot put a black hole on a scale. You cannot scoop it, hold it, place it beside a known weight, and compare. And yet, we know how heavy they are, how massive, how dense we know by watching what they do. Because gravity leaves fingerprints in the movement of stars, in the bending of light, in the rhythm of orbits. And gravity never lies. Let's begin with the simplest clue. A star that orbits not freely, but in a tight, fast curve. There's nothing visible at the center. No glowing sun, no cluster of mass. And yet the star circles again and again, pulled by something silent. This is how astronomers confirmed the black hole at the center of our galaxy, Sagittarius A. They tracked stars using infrared telescopes, watched them 4 years, measured their paths. One in particular, star S2, completes an orbit every 16 years at incredible speed, sweeping close to the invisible center. From its orbit alone, we can calculate the mass of what holds it. Over 4 million times the mass of our Sun, packed into a space no larger than a few light hours. No ordinary object could do that. Only a black hole fits elsewhere in the universe. We see similar signs in binary systems, where a black hole and a star are locked in orbit. We measure how the star wobbles, how it shifts in light, how it speeds up and slows down. From these motions, we calculate the black hole's mass in galaxies far away. We watch the stars near the center. We map their speed, their spread, their gravitational harmony. And the math reveals something astonishing. A black hole millions, sometimes billions of times more massive than the Sun, anchoring the whole structure. We also use light, or rather how light bends. Gravity curves space. So when light passes near a massive object, it follows the curve, not a straight path. This is called gravitational lensing. If a black hole passes between us and a distant star or galaxy, the light from behind bends, flares, splits. We can measure the amount of bending, the degree of distortion, and from that we estimate the black hole's mass. Even black holes that do not glow, that do not orbit near a star, can reveal themselves through lensing. A brief magnification, a flicker of brightness, a ripple in the background light of space. These are subtle clues, but they're enough. Even gravitational waves, the ripples in spacetime created by merging black holes, carry mass signatures. When two black holes collide, they send out waves trembling through space itself. And from those waves, from their speed, their amplitude, their frequency, we read the Surrey. We know how massive the black holes were, how fast they spun, how much energy was released. It's like listening to the sound of two drums colliding and knowing their size, their depth, their tone. This is the new way of weighing black holes, be their echoes. By the way, shake the universe. All of these methods, from starlight to space-time, give us answers about things we cannot see. It is a quiet triumph of observation, of patience, of inference, and it teaches us something gentle, that presence is not always visible. That influence is its own form of proof. A black hole may not speak, but everything near it responds. And in those responses, we find numbers, masses, estimates, not guesses, but measurements, confirmed, repeated, refined. You might find that reassuring, that the invisible can be known, that the unknown can be mapped, not directly, but faithfully. And perhaps that's true beyond astronomy, that weight, truth, and meaning often reveal themselves in how other things move, how they bend, how they orbit around a quiet center. Black holes don't need to shine to shape the night. They only need to hold, to curve, to wait. And we, with our telescopes, our equations, our patience, we read the space around them and learn what they are. In the next chapter, we'll follow these weights in motion to a spectacular cosmic dance where black holes collide, and the universe rings like a bell from the impact of their union. Black holes are often thought of as solitary, drifting alone in space, silent still. But sometimes they meet. Two of them, each massive, each slung, begin to orbit one another, drawn into aspiral, a cosmic dance. It's not a fast dance, not at first. It begins gently over thousands, even millions of years. They circle slowly, losing energy, drawing closer, tighter, faster. They do not touch, not in any ordinary way, but their gravity binds them. Their motion deepens, and as they move, they stir space-time itself, like heavy stones circling in a soft fabric. They cause ripples to spread outward, not in air, not in water, but in the very structure of space and time. These ripples are called gravitational waves. They carry energy, they travel at the speed of light, and they stretch and squeeze space as they pass. For a long time, we knew they must exist, but we had never caught one. That changed in the year 2015 when scientists at LIGO, the Laser Interferometer Gravitational Wave Observatory, detected the first wave. A soft pulse, a tiny tremor caused by two black holes colliding over 1 billion light-years away. They had spiraled into each other, merged and released a burst of energy greater than anything seen before, not in light, but in gravity. For a brief moment, that merger released more power than all the stars in the observable universe combined. And then it was gone. The black holes became one, a new, larger object, still dark, still silent. But the wave had already begun its journey, spreading across the cosmos and finally reaching Earth, where we listened. That moment changed everything. We were no longer just watching the universe. We were hearing it, feeling its tremors, reading its motion, not by sight, but by touch. Since then, we've detected many more black hole mergers of different sizes, different distances, some with massive spins, others with surprising masses. Each one tells a story of formation, of motion, a final union, and each time the universe becomes more alive, more dynamic. You might imagine it now, two black holes invisible, orbiting insolence, closer and closer. The moment before they touch, space-time around them, whirls like water circling a drain, and then they merge. No explosion, no flash, just a new ripple. A wave in the deep structure of reality that spreads softly, silently across galaxies, until it reaches detectors on Earth and stretches a mirror by less than the width of a proton. But that stretch is real, measurable, confirmed from that tiny movement. We learn the masses of the black holes, the distance, the energy of their union. We weigh their silos. We measure their final breath. And what's perhaps most beautiful is that we are only beginning. The instruments are growing more sensitive. The catalogue of collisions expands. We are building a map, not of stars, but of motions too dark to see. And each detection brings us closer to understanding how black holes form, how often they merge, how galaxies evolve, how gravity works in its rawest form. You're living in an era where we can listen to the sky not for sound but for gravity, for tremors left by events that happened billions of years ago. And every time we catch one, we become more connected to the cosmos, not just as observers, but as participants, as listeners, as storytellers, because each merger, each wave is a line in the poem of the universe, and we are beginning to read it. In the next chapter, we'll step back from collisions and turn to a stranger question. Could black holes themselves be illusions? Could what we think of as a hole in space be something else entirely? All this time, we've called them black holes. We've spoken of their mass, their hunger, their sen, their power. But what if they aren't what we think? This question isn't born from denial. It's born from curiosity, from the simple truth that black holes are built not from what we've seen, but from what we cannot see. They are in many ways ideas, solutions to equations, curves in a model of space and time. And while those models explain so much, there are still places where the story phrase, the center of a black hole, according to general relativity, lies a singularity, a point of infinite density, where the laws of physics break down. And that's a clue. When the math reaches infinity, when it no longer makes sense, it's not just a mystery, it's a signal that something deeper, something more complete might be waiting to be discovered. Some physicists wonder whether black holes are real objects or simply shadows, hints of a deeper structure. What if instead of a singularity, there's a core of exotic matter, something we've never seen, but that resists collapse in a new way? Or perhaps there is no event horizon at all. No true point of no return, but rather a surface-thin, dark butte reflective, in strange ways. These are ideas, not answers, but they point to a simple truth. Our theories of gravity, of space and time, are incomplete. We do not yet have a quantum theory of gravity, something that merges Einstein's smooth curves with the jittery, flickering world of quantum mechanics. Until we do, our picture of black holes might be like a sketch, clear from a distance, but blurred in the fine lines. There are proposals like the fuzzball theory from string theory, where black holes are not points, but tangled knots of vibrating strings, or the idea of graver stars, gravitational vacuum stars, where collapse stops, just short creating an object that mimics a black hole, but has no singularity. There are even more radical notions that what we call black holes are projections, holographic illusions, that space is encoded differently than we think. We don't have proof of these ideas, not yet, but they exist for a reason. Because black holes push every part of our science to its edge. They are tests of what we believe and what we can know. And still, even if they are not exactly as imagined, something is there. Something pulls on stars, bends light, shakes space with gravitational waves. Something so massive, so compact, so quiet, that it behaves like a black hole, even if its center is not a true singularity. Perhaps the name black hole is only part of the story, a placeholder for something we don't yet fully grasp. But this uncertainty is not failure. It's wonder. It's the reminder that science is a path, a journey. And black holes are one of its most mysterious destinations. They are not just objects. They are opportunities to question, to look again, to refine, to listen deeper. And so we do with new telescopes, new theories, new minds entering the field. We imagine what else they could be, what secrets lie beneath the surface of the models. What future discoveries will change everything we thought we knew? It is possible that one day the term black hole will mean something different, something richer, more precise. But until then, it holds its place. Not as a final answer, but as a beautiful question. In the final chapter, we'll step away from physics and equations and simply ask, what do black holes mean to us? Not as scientists, but as humans, looking into the quiet dark and wondering what lies beyond. You have wandered a long way tonight through spirals of starlight, into the folds of gravity, past the edges of what can be seen. You followed stars that burn out, watched galaxies curve around invisible centers, listened to the tremble of space as black holes collide. And now you find yourself not in front of a monster, but in front of a mirror. Because black holes, for all their mass and mystery, hold something deeply human. They represent our questions, the ones we ask when we turn off the lights and stare into the ceiling, feeling small but not alone. They represent the edge of knowledge, the place where equations unravel, where curiosity keeps going, even when certainty does not. They teach us that not all things can be seen, that the most powerful forces in the universe may not glow or shout, but simply pull. Black holes are about gravity, yes, about mass and time, but they're also about stillness, patience. They teach us that endings are not always what we think, that collapse can lead to new beginnings, that even when something falls beyond the horizon, its presence still matters, still shapes the space around it. There's something poetic in that, something we can carry with us long after the science fades from memory because we too have boundaries, edges we cannot cross, questions we may never answer. But that doesn't mean we stop asking, stop circling, stop listening. In fact, it is often the darkness that helps us understand the light. The more we study black holes, the more we learn about galaxies, about stars, about time, about ourselves. They are not absences. They are invitations to imagine, to explore, toss it with the unknown. They pull on us not with fear, but with wonder. And in the quiet space they create, we find something unexpected. Not nothingness, but depth. Not destruction, but transformation. You may never see a black hole with your own eyes, but you are connected to them by gravity, by motion, by story. You ride the spiral of a galaxy that turns around one. Your body is made of atoms once scattered, by stars that may have danced near one. Your mind now holds their shape, their shadow, their question, and that in its own quiet way is beautiful. Thank you for joining me on this gentle journey through space, through science, through sap. If these stories helped ease your night or sparked a little awe in your evening, consider leaving a quiet like or becoming a supporter through channel, membership, or a super thanks. It helps keep the space going, a space for calm curiosity. For sleepy science, for all of us who still wonder at the stars, sleep well and let your thoughts drift freely. Now there is more to learn, but for tonight, let the questions rest with